In Texas, Saronic Technologies is building something the US Navy hasn't had in decades: speed. Real industrial speed. Port Alpha is America's first naval shipyard designed to mass-produce autonomous warships, and it's already in motion. The logic is simple. China has numbers, over 350 ships. America needs speed. Port Alpha is closing that gap without waiting a decade. This is Port Alpha. Let's walk through what it's building, one vessel at a time. 6. Spyglass. Picture 6 feet of maritime mischief that fits where manned boats fear to tread. Spyglass is essentially a pocket-sized picket ship that you can launch off a beach, kick out the back of a rigid-hull inflatable boat, or deploy as a coordinated wolf pack that'll have enemy communications officers gasping for breath. Spyglass hauls up to 40 pounds of payload, sprints at 20 knots, and roams 30 nautical miles from home. That's plenty of range for harbor denial operations, some perfectly legal intelligence gathering in international waters, or reconnaissance swarms that make traditional patrol boats look like they're operating in slow motion. The beauty of Spyglass lies in its modularity. One crate, one mission profile, infinite possibilities. A former naval officer built the first unit practically in a garage to prove a fundamental point: deliver actual steel that floats and fights, not just slideshow presentations. Spyglass became Saronic's calling card, demonstrating that Silicon Valley cadence could produce legitimate combat power instead of vaporware. At 6 feet long, Spyglass infiltrates marinas, pier shadows, harbor cuts, and coastal clutter. Basically anywhere larger vessels get nervous and sensors get overwhelmed by background noise. Launch from shore, a commercial workboat, or a mothership. Recover, swap payloads, and redeploy within hours. When tempo becomes your primary weapon, this kind of operational speed creates decision-making problems for adversaries. 20 knots in a tiny package is remarkably lively. Accelerate into position, reposition before the enemy adjusts, vanish into harbor traffic. Inside that 30 nautical mile operational bubble, Spyglass completes the entire mission cycle: ingress, surveillance, optional engagement, and exfiltration, all without theatrical announcements. That 40-pound payload capacity purchases serious options. Mount electro-optical/infrared cameras for positive target identification. Add compact electronic warfare gear to probe enemy communications. Install a demolition charge for pier denial or propeller fouling operations. When circumstances require punctuation, you can even fit a loitering munition. Spyglass is essentially a maritime Swiss Army knife with an attitude problem. 5. Cutless. Meet the bigger sibling with sharper elbows, 14 feet of length, 200 pounds of payload capacity, and a 300 nautical mile reach. This is where Cutless graduates from being a demonstration platform into becoming a genuine network node that actually earns its operational keep. And classify surface contacts while maintaining safe standoff distances. Still hits that same 20-knot top speed, but packs 10 times Spyglass's range. What separates Cutless from smaller platforms is genuine autonomy with situational awareness. The vessel carries its own mast and radar systems, meaning it doesn't just blindly execute orders. Cutless sees, tracks, classifies, and maintains target threads without requiring constant human supervision. The artificial intelligence runs on a microservices architecture with open modularity, think smartphone app ecosystem, but for maritime combat systems. Deploy electro-optical/infrared today, electronic warfare tomorrow, loitering munition racks on Friday. The operational validation speaks volumes. During Integrated Battle Problem 24.1, Cutless launched Altius loitering munitions at sea. Mid-ocean, clean handoff, zero drama. That's not a science fair project. That's a floating missile caddy performing actual work in blue water conditions. The operator workflow is elegantly simple. Launch from a pier or mothership. Establish a patrol corridor at 20 knots. Deploy sensors across the area. Pass targeting data to shooters. And when authorization comes through, release a loitering munition. Then recover the platform, swap mission modules, and send it back out. Cutless occupies that perfect middle weight that commands respect. Too small to justify expending expensive anti-ship missiles on, too capable to ignore, and perfectly positioned to complicate life for anything wandering into its assigned sector. 4. Corsair. Now we're talking serious capability. Corsair stretches 24 feet, exceeds 35 knots, carries approximately 1,000 pounds of payload, and operates beyond 1,000 nautical miles from base. This vessel delivers genuine persistence with proper kinetic punch. Deploy it to tow sensor arrays, shadow foreign frigates, or park an unpleasant surprise just beyond the radar horizon. With 1,000 nautical miles of range, Corsair graduates from coastal operations to legitimate blue water missions. It sits on station for days, patrols entire sea lanes end to end, or transfers between task groups without begging for a refueling stop. The hull design centers on a modular mission bay. Rack whatever equipment the mission requires. Sonar arrays for submarine detection. Electro-optical/infrared masts for visual identification. Compact electronic warfare suites for signals intelligence. Radar packages for air search. Lightweight offensive racks when diplomacy ends and combat begins. One deployment cycle, Corsair plays logistics quartermaster, delivering spare parts, fuel canisters, even complete maintenance kits to units that can't break station. Next deployment, it grows a fake identity and runs deception operations, towing radar reflectors and emitters to project a signature 10 times its actual size. Burning enemy targeting cycles on Phantoms. Flip the payload configuration, and Corsair becomes a strike platform carrying munitions, ready to release autonomous weapons the instant a contact turns hostile, while the mothership keeps its precious vertical launch cells diplomatically closed. When stealth matters, Corsair goes full sensor dragger, streaming sonar arrays, deploying acoustic buoys, stitching together a real-time detection fence across contested waters. When the mission requires shadowing operations, Corsair tucks in at 35+ knots, matching a frigate's maneuvers, maintaining visual contact, and gathering intelligence just beyond the horizon. It's the persistent surveillance platform that never gets tired, never gets bored, and never files a complaint about extended deployments. 3. Mirage. Welcome to ship-sized presence, 40 feet of length operating like a traditional patrol craft for broad mission sets, maritime security, picket duty, deception operations, or escort duties within mixed crewed-uncrewed formations. Mirage packs 2,000 nautical miles of endurance, tops 35+ knots, and hauls up to 2,000 pounds of equipment when situations turn kinetic. This is the platform you assign geographic sectors to, not individual errands. Deploy 2 Mirages, and they write their own patrol patterns while your destroyer conserves fuel, crew rest, and expensive missiles. The operational philosophy centers on command presence without crew costs. Mirage runs the same browser-based command interface and mission-level artificial intelligence as its smaller cousins, so you're not retraining the entire fleet, just scaling the hull and mission appetite. Those modular equipment bays accommodate serious hardware, medium-sized radar arrays for surface tracking across significant ranges, tall electro-optical/infrared masts for positive visual identifications, compact electronic warfare suites for signals deception operations. When observe and report needs actual teeth, rack up loitering munitions. In escort configuration, Mirage runs dedicated wingman duties, screen a frigate or destroyer, mirror every tactical turn at 34+ knots, and hand off threat data to shooters with the calm professionalism of a veteran operations specialist. Deploy 2 Mirages, and they become a persistent pattern. 3 Mirages transform into an active network, cross-queuing targets, trading sensor tracks, rotating station assignments across that generous 2,000 nautical mile operational leash. This approach lets high-value surface combatants conserve fuel, preserve crew rest cycles, and save missiles for engagements that genuinely matter. Assign Mirage a sector. Consider that sector secured. It's distributed lethality without distributing your actual sailors into harm's way. 2. Cipher. 60 feet of length, 10,000 pounds of payload capacity, exceeding 35 knots, spanning 3,000 nautical miles. Cipher is a floating problem-solving platform for missions you'd prefer not risking actual sailors on. The defining feature? Cipher swallows a complete 20-foot ISO shipping container, connects it to ship power systems, and transports whatever equipment lives inside. Communications suites, electronic warfare laboratories, medical facilities, spare parts warehouses, even entire drone deployment systems. Let's examine the specifications. Length 60 feet, approximately 18.2 meters. Top speed exceeds 35 knots, roughly 65 kilometers per hour. Range spans 3,000 nautical miles, approximately 5,500 kilometers. Payload capacity hits 10,000 pounds, 4.5 metric tons. And yes, it handles standard 20-foot ISO containers, no bespoke mounting racks, no integration drama, just industrial utility at fleet speed. The operational value proposition centers on moving logistics at combat vessel speeds. Traditional cargo vessels plod along predictable routes. Cipher runs with frigate formations, changes operational sectors between dawn and lunch, and penetrates areas where replenishment ships won't venture. Roll on an electronic warfare container for signals intelligence missions. Deploy a sensor laboratory for environmental data collection. Install a drone magazine for autonomous aerial vehicle operations. Mount a mobile workshop complete with 3D printers, spare components, and repair benches. Roll off when the mission concludes. Same browser-based control system and mission-level AI as smaller vessels, so operators aren't learning exotic new interfaces, just scaling payload capacity and hitting the deploy button. Consider real-world operational sequences. In contested waters, Cipher becomes the invisible logistics train. Sprint ahead of the convoy, cache fuel bladders and critical parts on a remote atoll, then loop back to transfer strike packages from its containerized bay. Rush repair kits to damaged patrol craft without requiring vulnerable crew transfer operations. Shadow task groups at 35+ knots, functioning as a mobile magazine for loitering munitions and a communications relay tower for distributed swarms. After natural disasters, Cipher arrives carrying a medical ISO container, backup generators humming, and clean water purification equipment in the adjacent bay. It's humanitarian assistance, combat logistics, and strategic mobility wrapped in one modular package. Cipher represents the future of naval logistics, autonomous, adaptable, and impossibly fast for something hauling containers. 1. Marauder. The flagship of the autonomous fleet, 150 feet of unmanned maritime persuasion. This is Marauder, and it's not playing in the same league as anything we've discussed previously. Range spans approximately 3,500 nautical miles. Cruise speed settles around 12 knots with burst capability exceeding 18 knots, and payload capacity measures in 40 metric tons. Deck space accommodates 2 40-foot ISO containers, or 4 20-footers. You're looking at the capability to deploy missiles, mines, radar installations, fuel bladders, repair workshops, or entire pop-up mission modules into locations carrier strike groups won't risk. Position Marauder on a strategic choke point, lend it to a multinational task force, or let it play quartermaster for your autonomous flanking formations. When the operational brief says heavy, Marauder responds with, "How much do you need?" The strategic value lies in industrial-scale maritime leverage. Traditional logistics vessels require escorts and vulnerability assessments. Marauder runs alongside them, integrating Saronic's proven autonomy technology, holds assigned sectors, then quietly relocates the entire operational problem set 500 miles overnight. Roll on an electronic warfare container, functioning as a mobile signals intelligence node. Install a radar system creating persistent air surveillance. Deploy a drone magazine stocking dozens of autonomous systems. Mount a field workshop or medical ISO with backup power generation. Roll off equipment when missions conclude. The vessels incorporate Saronic's vertically integrated development approach and disciplined engineering methodology, using the same autonomy stack proven across their smaller platforms. So controllers don't learn exotic new systems. They just assign substantially larger missions. Operational tempo becomes the defining advantage. The construction happens at Saronic's acquired Gulfcraft facility in Franklin, Louisiana, backed by approximately $250 million in facility upgrades aimed at producing up to 50 autonomous vessels annually. That production capacity transforms single-hull deployments into genuine fleet posture. One Marauder on station, one outbound, one inbound, and suddenly your logistics challenges start solving themselves. Marauder can loiter for over 30 days, maintaining persistent presence without crew fatigue, without resupply drama, and without the human factors that limit traditional surface combatant endurance. It's strategic patience combined with tactical flexibility, exactly what distributed maritime operations require. The production revolution. Scale represents the genuine headline here. Saronic acquired Gulfcraft's Franklin, Louisiana facility, nearly 100 acres of shipbuilding infrastructure now dedicated exclusively to autonomous vessel production. Backed by approximately $250 million in modernization investments, this facility is engineered to produce up to 50 autonomous vessels annually. That's how you transform a single prototype into credible fleet architecture. Maintain one vessel on station, one outbound to operational areas, one inbound for maintenance, and your logistics problems begin solving themselves through simple mathematics. But Gulfcraft represents just Phase 1. Saronic announced Port Alpha, their purpose-built, next-generation shipyard designed from first principles around autonomous vessel mass production. The facility will likely be positioned along the Texas Gulf Coast, leveraging regional maritime infrastructure while applying manufacturing efficiency lessons learned from commercial industry. Port Alpha's design philosophy focuses on eliminating production inefficiencies, optimizing workflows, and creating manufacturing systems that maximize quality while accelerating delivery timelines. Think automotive assembly plant methodology applied to warship construction, modular components, standardized interfaces, predictable production rhythms. Traditional naval shipbuilding operates on decades-long procurement cycles. Design specifications get debated for years. Construction contracts face delays and cost overruns. Delivery schedules slip by quarters, sometimes years. Saronic's approach flips that paradigm entirely. Building on proven small vessel successes, the 6-foot Spyglass, 14-foot Cutless, and 24-foot Corsair launched in 2024. They're scaling production capacity without sacrificing delivery speed. The strategic implications ripple outward. China's People's Liberation Army Navy operates through numerical superiority. More hulls means more presence, more intimidation, more strategic options. America's traditional response involved building fewer, more capable, more expensive surface combatants, destroyers costing $2 billion each, aircraft carriers approaching $30 billion. Saronic's autonomous fleet offers a different calculation. Distribute capability across affordable platforms, accept calculated risks with unmanned systems, and out-tempo opponents through sheer production velocity. When you're manufacturing 50 vessels annually, attrition becomes manageable mathematics rather than strategic catastrophe. The strategic picture. Let's contextualize what Saronic is actually building. The US Navy faces a fundamental challenge, maintaining maritime dominance across global oceans against a peer competitor investing heavily in naval expansion. China's shipbuilding capacity dramatically exceeds American yards. Their fleet grows while ours struggles to maintain current numbers. Traditional responses: build more destroyers, more submarines, more aircraft carriers, hit economic and industrial walls. Those platforms cost billions, take years to construct, and require thousands of trained personnel. Even with unlimited budgets, which don't exist, American shipyards lack capacity for rapid expansion. The autonomous systems are vessels without crews, eliminates life support requirements, reduce platform size, lower construction costs, and accelerate production timelines. More importantly, they enable distributed operations, spreading capability across dozens or hundreds of platforms rather than concentrating it in a handful of expensive, vulnerable capital ships. Saronic's vessel family provides the Navy with operational flexibility traditional platforms can't match. Need persistent surveillance across vast ocean areas? Deploy Mirage formations operating for weeks without refueling. Require logistics support in contested waters? Send Cipher with containerized supplies. Want to complicate enemy targeting? Launch Corsair swarms, creating multiple simultaneous threats. The autonomy technology represents years of development investment. Each vessel operates using common command and control architecture, allowing single operators to manage multiple platforms simultaneously. The systems function in GPS-denied environments, communicate through contested electromagnetic spectrum, and execute complex missions with minimal human supervision. This isn't replacing manned vessels, it's augmenting them. A destroyer supported by 6 autonomous escorts multiplies its effective capability. The autonomous platforms handle dull, dirty, and dangerous missions, persistent surveillance, mine detection, decoy operations, while the destroyer preserves its crew and weapons for high-intensity combat. The China factor. Why does this matter specifically regarding China? The People's Liberation Army Navy has watched American technological advantages carefully. They've invested in anti-ship ballistic missiles specifically targeting aircraft carriers. They've developed sophisticated anti-access/area denial systems designed to push US forces away from Taiwan and the South China Sea. These strategies assume predictable American force structures, carrier strike groups, destroyer formations, submarine patrols. They've optimized sensors, weapons, and tactics against known platforms, operating in established patterns. Autonomous vessel swarms disrupt those calculations entirely. Chinese naval planners must suddenly account for dozens, potentially hundreds, of autonomous platforms operating across contested waters. Which ones carry sensors? Which packs offensive weapons? Which are decoys? Which represent genuine threats requiring expensive munitions? The mathematics become nightmarish. Expend a multi-million-dollar anti-ship missile against a $5 million autonomous vessel, and you're trading economics poorly. Ignore the autonomous vessel, and it might be forward deploying mines, gathering targeting data, or preparing to launch its own weapons. Saronic's production tempo accelerates this strategic dilemma. 50 vessels annually transforms fleet composition within years, not decades. Chinese military planners watching those production numbers must recalculate their entire Pacific strategy. Moreover, these platforms enable American presence in areas previously considered too risky. Can't risk a destroyer in shallow, contested waters near Taiwan? Send Corsair formations? Need persistent surveillance inside the first island chain? Deploy Mirage pickets? Want to complicate Chinese exercise operations? Scatter autonomous vessels across their training areas, forcing them to account for constant observation. It's strategic pressure through technological asymmetry, exactly the kind of competition China prefers avoiding. The broader defense revolution.
Track an enemy submarine for as long as it takes for the sub to make a fatal mistake.
Saronic represents a broader shift in American defense acquisition. The traditional model massive prime contractors, decade-long development cycles, cost-plus contracting struggles adapting to rapidly evolving threats. By the time new systems deploy, adversaries have developed counters. The company's $4 billion valuation reflects investor confidence in this new model. Smaller, agile companies applying commercial technology and manufacturing techniques to defense challenges. Silicon Valley speed meeting Pentagon requirements. The Pentagon's replicator program specifically aims to acquire swarms of expendable unmanned platforms, exactly what Saronic provides. Rather than treating autonomy as distant future technology, the Department of Defense is incorporating these capabilities into current force planning. Other companies are watching closely. Success breeds competition. If Saronic proves autonomous vessels deliver operational value at reasonable costs on acceptable timelines, expect similar startups targeting other naval niches: submarine drones, autonomous aircraft, unmanned logistics systems. The Navy is betting on this distributed, autonomous future, not replacing sailors, but multiplying their effectiveness through technological leverage. One operator managing 6 autonomous vessels delivers more presence, more capability, more strategic options than traditional single-platform assignments. The reality check. Now let's inject some necessary skepticism. Autonomous systems aren't magical solutions to every naval challenge. They face genuine limitations. Autonomous platforms must function for extended periods without human intervention. Mechanical failures, software bugs, or sensor malfunctions in remote waters become serious problems when there's no crew performing troubleshooting. Not forgetting that autonomous systems also depend on communications, GPS navigation, and sensor feeds. Sophisticated adversaries will jam, spoof, or hack these connections. Saronic claims their vessels operate in contested electromagnetic environments, but real-world testing against peer competitors hasn't occurred. Another major challenge is that of integration. Adding dozens of autonomous platforms to existing fleet operations requires updating tactics, training, and logistics. The Navy must learn to operate alongside robotic vessels, not trivial organizational change. Also not forgetting maintenance and support with cost realism. Despite these concerns, the fundamental strategic logic remains compelling. America needs more naval presence across more oceans faster than traditional shipbuilding delivers. Autonomous vessels provide a path forward, even if that path includes challenges requiring solutions. Here's the uncomfortable truth. Naval competitions aren't won through individual platform superiority. They're won through industrial capacity. World War II's Pacific Theater demonstrated this principle decisively. American shipyards produced Essex-class aircraft carriers faster than Japan could sink them. Industrial momentum, not tactical industrial momentum, not tactical brilliance, decided the conflict. Today's competition follows similar logic. China builds ships at remarkable pace. Port Alpha and Gulfcraft represent America's countermove. Should Port Alpha deliver on its ambitious promises, it births an autonomous fleet that substantially multiplies US Navy capabilities. The race isn't just about who builds better ships, it's about who adapts faster to new technological possibilities, who reorganizes their industrial base more effectively, and who accepts greater risk with innovative systems. China's watching. Russia's watching. Every naval power is watching what happens when a Texas startup decides the rules of shipbuilding need rewriting. And the smartest observers are asking themselves, if Saronic succeeds, what other defense assumptions need challenging? What other industrial processes need disrupting? What other Pentagon problems need startup solutions? That's the real story Port Alpha tells. Not just about autonomous boats, but about whether American innovation can still outcompete authoritarian industrial capacity when motivated, funded, and unleashed. Place your bets. The race is already underway. That's it for today. Smash that subscribe button and hit the bell icon so you won't miss what's coming next. Thank you.